Hello, in this lecture we will discuss more elaborately about the merger table and merger graph and how this table and graph will help us to solve, or to, rather specifically to say that we can reduce the number of states in an incompletely specified machine. So let us solve some more problems. In the last lecture I have given one example. Five states. Now for this table, let us see that is there any compatibility is possible for A and B or not. So obviously for A and B there is no compatibility is possible, right? Because for I3, E and B both have so for I3 we have that E1 and B0, so the outputs are different. Now let us check for A and C. For A and C whether compatibility is possible or not. For I1, for A and C the outputs are different, same. Sorry, for I2 the outputs are same. For I3 also I can say that the outputs are same because one output is not specified, and for I4 the outputs are same. So I can say that A and C may be compatible, and there is no implied state. You can say that there is no implied state. So from A to C I am drawing one compatibility graph. Now let us check for I3, A and D. For A and D, for I1 the outputs are same, for I2 the outputs are same, for I3 the outputs are same, but in this case the implied state is specified, right? And for I4 the outputs are same. Now A and D can be said to be compatible if their implied state EB is compatible. Now check for EB. For EB the output I1 outputs are same, I2 outputs are same, I3 outputs are same, and I4 outputs are same. So I can say that A and D is compatible. A and D is compatible, and its implied state is BE. Its implied state is BE. Okay. Now let us check for AE. For AE, for I1 outputs are same, for I2 outputs are same, for I3 outputs are same, and EC is the implied state, and I4 outputs are same. Now check that for AE the implied state EC is compatible or not. Now for EC, look at this, all the outputs are same. So I can say for AE is compatible, and its implied state is CE. Implied state is let us check once again. Yes, CE. Now let's check for BC. Let us check for BC. Now for BC, I1, I2, I3, I4 all our outputs are same, but it doesn't have any implied pair. Okay. Now for BD, I1 outputs are same, I2 outputs are same, I3 outputs are same, I4 outputs are same, and for I3 next state is explicitly specified, but it is not an implied state, it is a single state. So I can say that BD is compatible, but it doesn't have any, BD I think has one implied state, that is AE. So I have to check the compatibility for AE. As AE I have a straight line, so I can say that AE is also compatible. So what I have to do, that I have to draw a line from B to D with AE, B to D with AE is its implied state. Now let us check the compatibility for B and E. B and E. Now for BE, outputs are same and implied state is BC. For I2 outputs are same, for I3 outputs are same, implied state is BC again. For I4 the outputs are same. So let us check the compatibility for BC. For BC I have a straight line, so I can say that BC is compatible. So I have to draw a straight line from B to C, B to E, and its implied state is BC. Implied state is BC. Now let us check the compatibility for CD. Now for CD, for I1 outputs are same, for I2 outputs are same, and implied state is DE. I3 and I4 outputs are same. Now for ED, let us check whether it is compatible or not, and for ED I can see that it is compatible, but I don't have to check the ED's implied state, it will be checked later on. So I can say that CD is compatible and its implied state is DE. Okay, next is CE. For CE, BC outputs are same and implied state is BC. I2 outputs are same, I3 outputs are same, and I4 the outputs are same and implied state is AB. Now as AB doesn't have any compatibility, because the AD in between AB there is no there is no straight line is present. So what can I do, that I have to draw DE first. I have to draw DE and its implied states are BC, I am doing for CE, I suppose. CE implied state is AB. CD, okay, I made one mistake, I think. For CD it is implied state is DE. For CD the implied state is DE. For CD the implied state is DE, and for CE the implied state is AB. For CE implied state is AB and BC. AB and BC, but AB is not compatible. Now let us check the compatibility for DE, whether DE is compatible or not. DE will be compatible if BC is compatible, and BC has one straight line in between them. So I can say that DE is compatible and its implied state is BC. So draw the implied state for AB is BC. ED is BC. So let us check once again. Okay, now look at this. This is my merger graph. Now look at this, as AB is not compatible. So I can say that B is not compatible, right? AB is not compatible. So CE is not compatible, right? Now I have to check that whether CE is an implied state anywhere or not. CE is an implied state of AE. So as CE is not compatible, so AE also cannot be compatible. So AE also cannot be compatible. Now check for whether AE is implied state somewhere else or not. Yes, AE is an implied state in between BD. So as AE is not compatible, so BD will also not be compatible. Now I have to check whether BD is compatible somewhere or not. No, sorry, implied state is in somewhere or not. So, but BD is not an implied state anywhere. So this is the refined merger graph, where I have to delete BD, I have to delete AE, and I have to delete CE, as they are not compatible. So let us draw the refined merger graph again. So I have to draw somewhere else because I have a space constraint. So I am drawing this merger graph. What happens? So A to C, one straight line is there, then B to C there is another straight line, C to D is another straight line, in between C to D there is DE. Okay, then ED there is one straight line, and in between that there is BC, and then AD, in between AD there is BE. Then there is BE and AD, and then CD, and then B to E. B to E there is BC. B to E there is BC. So is there anything that I left? B is there, CD is there, AC is there, AD is there, ED is there. Okay, fine. Now let us delete this one. Now what I have to do, that from that merger graph I have to draw the minimal closed covering. I have to find out minimal closed covering. first draw the compatibility graph to find out the minimal closed covering. So AB doesn't have any implied state, AC doesn't have any implied state, AC and AD to BE is there, then I think AD to BE, then AE is not there, then BC doesn't have any implied state, then BE, then B to BC is there. So, I can draw B to BC, then BD doesn't have any compatibility graph, then CD is DE. So, CD to DE is there, then CE is not there, then DE to BC. So, DE to BC. So, DE to BC is there, D to BC is there, AD, BC and AD to B, B to BC, I think B, B to BC is there, okay fine, B to BC is there, BC, BC to AD, in between BC I think AD is there, in between BC AD is there, okay, I forgot to write this one, in between BC AD is there. So, BC to AD there will be another straight line. So, if I draw this again, so let us draw this again. Actually, there is due to the space congestion, let us draw this again. Over here I have AC and I have AD to BE, I have BC to AD, B to BC, then D to BC and CD to DE, CD to DE and V to BC, okay fine. So, it is okay. Now, this is my closed set of compatibles. I have to find out first closed set of compatibles, right? Closed set of compatibles. Now, within this closed set of compatibles, you can find out if you consider this closed loop where AD, BC and BE is there. So, you can say that all are closed set of compatibles because AD and its implied state is BE, BE and its implied state is BC, BC and its implied state is AD, right. Now, this one is closed set of compatibles. Whether it is covering, yes, it is covering because it is A, B, C, D and E, all states are present over here. So, it is covering also. Now, is this minimal? Obviously, it is minimal because I have 5 states. For the 5 states, minimum number of pair of states will be 3. So, 3 pairs are there. So, I can say that this one is minimal closed coverings. So, this is my answer where AD, BC and B can form the minimal closed covering, that is with this one I can reduce the machine further. So, let us draw the reduced machine then. Alpha, beta, gamma. So, if you find out that what should be the value, as if the table is with you, then you can find out that alpha is AD, I can take A or D, any one of them. So, as these are dash, then next one is E1, E1 is gamma 1 and dash. For beta it is BC, I can take B or C, any one of them. So, if I take B only, then C is beta. So, it should be beta 0, then alpha 0, then again beta 0, and B value is beta or gamma, right. So, I can take B B value as beta or gamma, any one of them. So, beta by gamma, then 0 dash. Next one is for gamma. Gamma value is B or E, I can take any one of them. So, let us take B only. So, if I take B only, then B value is C0, that means beta 0, then alpha 0, beta by gamma 0, then dash. So, these results can vary from one results to another results.